Hey guys, this is Nishant. What you're seeing in front of me is a project I've been working on recently. This is based on a Raspberry Pi that I got recently and have been fiddling with it, trying to understand what's capable of doing. I set out to basically build a remote control car that I can control remotely and see what is in front of it. So it's a pretty cool idea, but the important thing was to kind of understand what Raspberry Pi can and cannot do, so I can use it in future projects. What the setup is basically a remote control car whose case has been pulled out, as you can see, and I fitted with Raspberry Pi motor controller, and it's powered by a portable micro USB charger. The motor is driven by its own power supply, so it doesn't strain the Raspberry Pi and cause issues. So currently it's not streaming anything, it's completely powered off. And let's go ahead and connect. And okay, so there is another screen in front of me. This is the motor server, which basically transmits keys to my Raspberry Pi, which in turn controls the movement of the wheels. As soon as it's powered on, we should see some images coming in, hopefully of me, because as you can see, the camera is kind of facing me right now. This tiny little dot in front of me, and you should also see the client connect to the server, and you should see client connected message and waiting for keystroke. So let's go ahead and power up this this machine. So I've loosely connected the micro USB for the Raspberry Pi. I'm gonna just fit that in so it goes in. So the Raspberry Pi is actually should start booting right now. I'm also gonna go ahead and connect the power supply for the motors. So this is good. So as you can see, the red dot, I don't know if you noticed, that's the motor controller's power light. So it means that it's kind of turning on. So let's give it a second for the Raspberry Pi to start streaming images. So the blinking LED light that you're seeing in front of me is that of the Wi-Fi adapter that is connected to the Raspberry Pi. It starts glowing. Oh, there it is. The images of me taking a video using my phone camera clearly has started coming in. There's a little bit of lag. It's not as real time as I would like it to be, but I can make it better when I have some time. But it's good enough for now. So the other thing you should notice is that the message on the screen has changed to client connected, waiting for keystrokes. So the Raspberry Pi can be controlled using my keyboard right now if I want to. So everything is done. Let's control this Pi / car with our keystrokes. So I'm using WASD key here. W for front, S for back, A for left, and D for right. As you can see, the front wheels are actually facing me, which means they're gonna turn when I press A. Let's go ahead and press A. Oh, as you can see, it moved. D for the other way. And let's go ahead and control its forward back motion. You should see all four wheels turn towards me. So all four wheels are turning, and stop by pressing back once. Also interestingly, I've coded in the acceleration part, which means if I press W twice, it'll go twice as fast, and if I press S twice, it'll go back twice as fast. Let's go ahead and test that. W once, twice, thrice. So it's visibly faster, and I'm stopping it, and then I'm going to press S again. It's going back, and again. again, and stop. Now, so the car seems to be working. It's on a stand, so it's not going anywhere. So let's try to put it down on the floor and watch how it goes. Gonna lift the pie now, gently, without dropping a wire or getting tangled in this mess. I clearly haven't done a good job at putting these pieces together. I'll probably find someone to do it for me, or do it myself when I have some time. So I have a keyboard in front of me. I'm gonna slide it along so you can see what I'm gonna be pressing. So move it all the way to the edge. So I'm going to be pressing the W key to make it go top front. So you should see it start crawling front when I press W. It's slowly moving, and I'm going to stop it by pressing S. I'm going to see how it's turning. So A for left, so it's turning left. I'm going to make it go front a little bit and make it go faster. So now I stopped it. I'm going to make it go back and turn towards me and stop. Okay, so it works. So that's the demo of the project. Now I'm going to talk a little bit about what it took to get this up and running. You can also see the image that is streaming right now. It takes a lag of a second to do it, to get us the actual image of what it's saying. I'm going to lift it up and show you. I don't think you can see all the key components, but I'll try my best to explain it. So as you can see on top is the micro USB power supply. It is controlled by motor controller, the red plugs that you see along the side, the powered up light, that's where the motor controller is. The Raspberry Pi is actually sitting below the green chip that you can see, and it is a Raspberry Pi B+, which means it has 4 USB ports conveniently, and it also has a HDMI display output, which is kind of free right now, that I could use to kind of see what's going on. Have a breadboard to actually control the power to the motors. It's not required. I just wanted an easy way to plug on and off the motors. It could have been made simpler. So that's the hardware part of it. There is more details to it. Obviously there's a camera that is connected to the Raspberry Pi board, and the Wi-Fi adapter as well. The car is a remote controlled car. I bought it on Amazon. It's not that expensive, and it comes with a shock absorber and stuff like that, so you can run it on the road if you wanted to. So let's go to the software. So what you're seeing, let me put this down. So what you're seeing right now is the MP moving JPEG streamer. Given a stream of images, it knows to kind of coalesce them and show it in as a streaming display. Oh, there it goes. The image just changed. There's a little bit of lag. So due to the way it's implemented, basically the lag is expected. I'm working on improving it so I can see more real time, but nevertheless it's not going to be as smooth as like near real time. So that's the setup for the images. The setup for the keystroke for motor controller is basically a Python server running an EC2 machine, to which the Raspberry Pi connects to and receives the keystrokes and knows what to do on each keystroke. that's not very difficult once you know what GPIO pins are, and it's very and understand the basic motor controller uh, concepts. You should be able to figure that out. The motor controller is a L298N, which is basically, you cannot see here, I'm sorry about that. The motor controller is an L298N, and you can control the direction of the current. You can also control how much current is flowing as well, which means you can make the motor go faster or slower, which is pretty cool. So once the keystroke is received by the Pi, it basically issues some GPIO signals to control the motor controller, which indirectly controls the motors. So that's pretty much it. If you have any questions on how to implement it for your project, or if you just want to understand how it was done and what went into it, and if you want any details, feel free to email me or just chat. My Gmail ID is nishantrayan@gmail.com. Looking forward to hearing some feedbacks, and leave a comment if you think it's a cool idea.